we started last time was calculation for walls, that is in the superstructure itself. We have already done this for the substructure. Okay, and what we discussed last time was what section we are following, some key measurement principles. Okay, and what else? Yeah, we stopped here. That we have to the dividing line between the wall of the substructure and superstructure is the DPC level, and the difference in the wall may not be in the type but maybe in one of these things. Okay, we may have the same type of wall but we may be using different material, or the prices can be different, and so on and so forth. Okay. So how many types of walls we can have, and this is on the basis of material. Okay. So we have brickwork wall, blockwork wall, stone masonry, and special types. Okay. One of them is made up of concrete, which is blockwork. Okay. Brick is made up of clay basically, and stone masonry, right? And then there are some special types as well. We'll go through them. So if you are making a brick wall, then the important element is the type of bond you are going to use between the bricks. Okay, so you can see different types of bonds here. Bond meaning the arrangement of the bricks. Okay, the type of bond means the arrangement of the bricks. Okay, so here you can see the running bond. Okay, in all these figures except this one, you can see the bonds or the bricks are not one over the other. Okay, they are not. So this one is stack bond, which is where the grids are like a grid. Okay, so one brick, one brick, one brick. Okay, but in all the other types, you see that the bricks are not one over the other. Okay, so this unevenness gives them a better bond. Okay, or it helps us save the material as well. Okay, in the end, when you go with this type of structure, the last portions of the wall are normally wasted. Last portion of the bricks are normally wasted. You have to break them. Okay, but with the other types of bonds, you have less wastage of material. Okay, because it is uneven, so you can put like a small bricks and a small parts of the brick somewhere as well. Okay, so you have running bond, you have common bond, you have English bond, and you have Arabic bond, right? No, Flemish bond. Okay, this is also sort of Dutch. You should come up with an Arabic bond as well. By the way, they have English, they have Flemish. No? One of you should come up with an Arabic bond. So this one is like a grid. This one, where the bricks are facing the same way. Okay, in the running bond, the bricks are facing the same way. Okay, so all of them are lengthwise facing the outside of the wall. Okay, this is the length of the brick, and they are facing in this way. In the common bond, English bond, and in Flemish bond, you can see all bricks are not facing in the lengthwise. Okay, for example, if you take this one, the common one, you have bricks in the top row, you see the longer dimension, right? And in the second row, you see the shorter dimension. Okay, so one row like this and the other one like this. Got it? Okay, so one is lengthwise, the other one is widthwise. Okay, and the same thing which you see in the English bond as well as in this bond. Okay, sorry, in the common bond you have one row, one or two. Yeah, you have like one row which is lengthwise, and then one row which is widthwise, and you have 3 and 4 rows which are lengthwise, another widthwise, and so on and so forth. In the English bond, they are alternate. Okay, one is lengthwise, the other one is widthwise. Okay, so in one case, in one row I put the bricks like this, in the next row I put the bricks like this. Okay, clear? And then we have the Flemish bond, where what is happening? Somebody tell me? Yeah, so we have bricks in this way and the next one in this way. Okay, so even in one row they are not the same. Okay, the first brick in the first row is this, second brick is this. Okay, and then third brick is again this. Okay, so it's changing in the row as well. And then you have the stack bond, where all the bricks are one over the other and they are in the same alignment. Okay, so these bonds are very important for the construction. You have to mention it, what type of bond we are using. Okay, for the bricks, the quality of the facing, like you will not get a smooth finish like this with bricks. Okay, and normally we don't use plaster as well, because plaster doesn't stick very well with the bricks. Okay, so if you have seen brick walls, maybe in the movies or something, you may have seen it here as well. It's not very common because of the material. Okay, we don't find the material for bricks here. Okay, our sand is different. If you go to areas which have rivers, okay, then the clay which you need for making the brick is very common there. Okay, especially very common. It may be in some other areas as well, but near the rivers the soil is very good for taking the material for bricks. Okay, so that's why we don't have it. But bricks, to be they have their own natural finish, and this is it. Okay, no plastering and no even if you do the paint, it will not look good. Okay, you can see the bricks itself. Okay, so even in bricks, then you can use different material, okay, which can give you different types of finishes. So we cannot do, so you can make any type of concrete block, because then you will do the plaster and the paint, right? With bricks, it's not there. Okay, so you have to decide, are you using the common bricks or you are using the finished bricks, and so on. So everything you have to do with the making of the bricks itself. Once the brick wall is ready, it's ready. Okay, it's done. Okay, yeah, and then we have engineering bricks as well, which provide better strength. Okay, so bricks are by default not good strong materials. Okay, but then you can do some mixing, some changes in the mixing of the bricks. Okay, maybe use better bonding material within the mix of the bricks, and it can give you some engineering properties as well. Okay, it can, then you can use it in structures like foundations. Okay, but normally bricks are not for structures, they are for walls. Okay, then we have block work, which is made up of concrete. Concrete, as you know, is a dense material. Bricks are usually hollow from the inside. Okay, we have different types of concrete. We have high strength concrete, normal strength concrete. We have talked about blinding as well, if you remember, which you put under the foundation and under the wall. That is also a concrete type of concrete, but that is very weak. Okay, so all those type of concrete can have their blocks, right? So the blocks can be dense, it can be lightweight, it can be aerated. Aerated is very good for the walls. Aerated means what? Anybody? Any idea? Aerated means what? Any idea? Good for the walls. The name itself is telling you. Aerated means what? Huh?
Like it's maybe so it's easy to
Irritate is what you are doing now, right now.
It's something like that. It's easy to B shape.
B shape, okay. Aerated comes from the air. Okay, so aerated blocks have air induced in them, not because of lack of compaction. If you do not compact the concrete properly, it will have air bubbles inside. Okay, that is not aerated. This is your laziness. Okay, we don't want to do this. There are some blocks which are specially designed as additive blocks. Okay, so we do the compaction and then we induce error in them. We put some chemical in them which will later on have some air which will.
When we use them?
Uh,
When we use them?
so yes, I am coming to that. These edited blocks, they are lightweight because of the content of the air. Okay, they are good where you have where you need resistance against moisture, resistance against temperature, and so on. Okay, because these air blocks will absorb these type of things. They will not let it go to the other side. Okay, so that's where we use them. So they are lightweight and good for insulation, and in the end, easy to cut. I don't know, but they will. Okay. Typical uses, you can use it inside of the cavity wall. We already discussed cavity wall, or the inner face of the cavity wall, the face which is inside the building. Okay. You can use it for partition walls. You can use it for foundation wall. Foundation meaning underground, the walls which are underground. It could be for even basements as well. Okay. So these block works can be used there. Then we have stone masonry. We don't use them. Again, material problems. Okay, stone masonry is not very common. Have you seen it? Stone masonry? Where? Huh? Old buildings, yeah. The forts we have, the Rifa fort, and the old forts they use stone masonry. Okay, so stone is very strong, very strong. Okay, but then it has a problem of finishing, it has a problem of carrying, it has a problem of molding, and so on and so forth. Because you are working on the natural material itself. Obviously now we have better equipment to do it, but we also have the problem of money. We also have the problem of resources, because you will cut the stone from somewhere, right? It's a natural material. You are not making it in a factory. Okay.
But still they are using it for curing.
For yeah, but the use is very less now. Okay, the old forts, even if you go to Pakistan, the buildings which are less than 100 years ago, they are fully made up of stone, fully, top to bottom, complete. Even like this building, how many floors you have? 2 floors, right? So a building this big, complete with stones, not this big actually, bigger than this. Okay, because those are courthouses. Okay, so they need like big halls. So they have like 2-3 floors with big halls. Okay, and each of these halls is like 2-3 of these rooms. Okay, so the use is very less now. Okay, then we have different types of stones. We have natural stone, rubble. Okay, we have ashlar stone. Okay, which is basically you find from you have to dig a little bit inside, and it is made up of minerals. Okay, ashlar stone is made up of minerals, and then we have the cast stone, which looks like a stone. It's actually concrete. Okay, so cast stone is what looks like a stone, but it's made up of concrete. And then you have the benefit if you are using cast stone, because it's made of concrete, you can make it into any shape and size and so on. Okay, but the what do you call the face? Okay, the look will be like you're using a stone. Okay, then we have the special types, which is glass block work. I don't know where it is used. We have the hollow walls with cavity. We already talked about it. Okay, but you can have hollow blocks as well. You can have hollow blocks as well, not 2 blocks and cavity. You can make a block which has cavity inside it. Okay, and then you have diaphragm walls, which has very thin layers on both sides. Okay, and they are connected by ties. I don't find anything. Okay, so it's like this. Okay, and between them they have ties because they are very weak. They are not made up of blocks. It's like a sheet. Okay, it could be as thin as this. Okay, so you have a sheet here, and obviously they will not stand like this. They will fall, right? So between them they tie with each other. They are tied with each other. So this is called the diaphragm wall, and these walls, they have less self weight. Like I said, they are very thin walls, so their own weight is very low. So if you are making very tall walls, if you make it with blocks, concrete, stone, brick, the wall is 10 meters, so the weight of the wall will be too much. It will be very high. Okay, if the wall weight is very high, that means the wall is where? On the ground, right? On the floor. So your slab also has to be increased. Okay, you will need a stronger slab for that. Okay, so instead of that, you can go for hollow walls or diaphragm walls or glass block work. I don't know. It's there. Okay. If you go with one of these options, then the weight will be less, especially the last two. Glass, I'm not so sure, but glass gives good appearance, right? Okay. Irrespective of the type, it is all measured in meter square. So whatever type of wall you are using, it doesn't matter, it is measured in meter square. Now which meter square we are talking about? What into what? Length into height. Okay, the face of the wall into height. Okay, and that means we do what with the thickness? We do what with the thickness? No, should we ignore the thickness? Okay, the wall is 20 square meters. That's it. Is it enough? The thickness is in the description. Okay, you have to remember the rule. If you are putting something in meters, that means the area is where? In the description. Okay, if you are putting something in numbers, I need 10 doors of this type. I'm not giving you the size. I'm not giving you the material. Where is it? In the description. Okay, so same thing goes for all types of walls. Okay, if the material is changing, then the BOQ item will change. If the quality is changing, the material quality is same. If the bond is changing, I showed you the bond, right? Changing the bond, then it will have different rates as well. Or the contractor needs to see that this wall is with this bond and this wall is with this bond. So you make it into different items then. Okay. And what else? Yeah. Mortar specification. What is a mortar? Water cement ratio without? Without aggregate, yeah. Without aggregate, I don't know. When you guys say concrete, it's made up of what? Tell me. Cement and aggregate, yes. So yes, without aggregate in that case. And when we were taught, they said, okay, you have two aggregates. Sand is fine aggregate and the aggregate is a coarse aggregate. But in your case, okay, without aggregate is a mortar. Okay. So the mortar specification is changing. Maybe you are using a different type of cement, sulfate resistant or something. Okay. Or you are changing the ratio of sand and cement and water. Okay, this is change. These are changes in mortar. Okay, the mortar changes, the rate will change. And if you have any special features, for example, I already mentioned the finishing. Okay, so for any of these things, you should make a separate item in your BOQ. If all of these things are same, then the entire building, wall of the entire building can be covered in one item. Okay, there is no classification of any other type. Okay, so if these things are constant, you have only one thing to worry about. You have only one item. Okay, these are the NRM references and the things you need to mention in the description. Okay, and they are given. I already mentioned the section number. It was 14 or something. Okay, so all of them are in the same section. Okay, you can have a look at it, and these are mentioning the same thing. If it is block work, type, thickness, face, and so on and so forth. Okay, this I already mentioned. Yeah, openings. So you have a wall, this wall, right? Okay, this wall has windows in it. This wall has a door in it. Okay, when you calculate the quantity initially, you will take it complete, including everything. like there is no wall, no windows. Okay, nobody will come in, nobody will get out. Later on, once you calculate the walls and the doors and the windows, you will then subtract it from the total. Okay, subtract it from the total. Okay, so like we did with the backfilling, you don't calculate the backfilling separately. Okay, you calculate excavation, you calculate concrete, and then you subtract and you find the backfilling. Okay, so same principle goes here. Okay, so walls can be, you can divide your measurements, your dimension sheets into normally these three things. We have external walls, we have internal walls, and we have projections or piers. Okay, this one most probably is a column, but if it was not a column, it will be called a pier or a projection, something which is coming out of the wall. Okay, but made up of bricks or blocks. Okay, so external walls are normally hollow, they have cavity or something like this to provide the insulation. Okay, and if they have cavity, then you have to calculate each face separately and then the middle material separately, and we have done this for the substructure. Okay, the contractor may charge you for forming the cavity as well, because the between the two faces you may not have empty space. Okay, because then the walls can, they can be unstable. Okay, or there can be water leakage inside, or plants can grow or something. Okay, or bacteria, animals and termites. So we need to keep the point or the space between them safe as well. Okay, so the contractor may charge you for forming the cavity as well, although it is called as cavity, which means nothing, but the contractor may charge you because practically you cannot keep it completely empty. Okay, so he will charge you, so you have to calculate the quantity of the cavity as well, the material which are you going to use the cavity. Okay, it can be made up of rigid sheets, so you put sheets inside the cavity, so you will calculate the quantity of the sheets in that case. Okay, if they are not sheets, they are just forming them, then the contractor will take the charges only for the labor work. Okay, but if they are the sheet, obviously he will charge you for the sheet as well. Okay, what else? Yeah, if you are using any specific type of insulating material, any damp proofing or something, then that should be mentioned as well. Okay, for the walls, we always take the center line length. So if you are calculating the area of the wall, this is an example. You take the center line length of the wall, multiply by the height of the wall. Okay, and the height does not include slab or beam or anything. Okay, because it's block, it's different material, it's not a choice. Okay, there is no choice here. And you can see there the thickness is mentioned, the type of material is mentioned. Okay, and the size of the brick which they are going to use is mentioned. Okay, so there are two types of sizes here, two types of volumes here. Okay, one is the volume of the wall and one is the volume of each block in the wall. Okay, so if somebody asks you what is the volume of the wall, center line length into height into thickness, this will give you the total volume of the wall. Okay, but each block in the wall is made up of 215 into 103 into 65. Clear? Okay, so and you can see the ratio for cement mortar is also mentioned. Okay, the ratio for cement mortar is also mentioned. 1:3 means what? 1 cement, 3 sand. Sand. Cement sand. What? Cement sand. Water is mentioned as what? Anybody? How do we mention water in the mixture of concrete or cement or something? Meter cube, water? You calculate the quantity of water when you are doing the design, yes. But how do you mention the, how much, ratio, right?
Yes.
Okay. So do we mention the water in the same way, 1:2 something? Yeah? Yes.
water cement ratio.
Water cement ratio, but we don't write it like this. Percentage, yes, percentage. It's a ratio, yes. Ratio with respect to cement, but the percentage. Okay. So when you see something like this for a concrete or cement mixture, it is the solid items. They are solid items. Okay. And this is taken from this part of the NRM. Okay. You can see here type of material mentioned. What type of wall you are using, it should be mentioned. It's hollow, right? Mentioned hollow wall. Okay. Method of forming, including the bond and everything, it should be mentioned. Okay. The type of construction you are using, all these things should be mentioned, and they are mentioned. Yeah. So this is the NRM part for the cavity formation. Again, you need the same thing: center line length multiplied by the height. Okay. And what else? So you can see cavity is filled with some sort of insulation. It's not empty. The insulation is 70 millimeters thick, the insulation sheet. Okay. And what else? And it is made up of board sizes of 1200 by 450 millimeters. So what we are putting inside the insulation? Sheet boards. And each board is 70 millimeter thick, 1200 millimeter long, and 450 millimeter wide. Okay. What else? And it is rigid, and it is core face both sides, and low emissivity composite. It's a type of material. Okay. Okay. This is the projection I was talking about. So it's not the column. It's made up of the same material as the wall. Okay. So we cannot consider it as a column. It's a projection or a pier. So if you have a pier or a projection, this can be calculated as a separate wall, or this can be taken as part of the wall. Okay. NRM gives you both depending upon what is the thickness of this projection. Okay. What is the thickness of this projection? If the thickness is less, it can be taken as in linear units, or if the thickness is more, it will be taken as square meters, same as a wall. Okay. The NRM standard. Okay. And this is the thing. Okay. This is the rule here. Okay. If, for example, my thickness of the projection is 250, okay, I multiply this by 4, I get 860. Okay. What is the length of this projection? It is 440. Okay. So thickness multiplied by 4 is more than the length of the projection. Then it should be considered as a separate wall. Got my point? Huh? The block work for the projection. Okay, so this projection, the block work for this projection can be calculated as a separate wall, or it can be calculated as just an extra line in the same wall. Okay, where is the limit? This is the limit. What is it showing? Thickness multiplied by 4. If it is more than the length, then it should be like an extra wall. If it is less than the length, then it will be taken in linear units. Okay. So in this case, you can see it is more, right? Okay. The 4 times thickness is more. So I think I said the other way around. If 4 times thickness is more than the length, we will take it as linear units. You can see this is the projection. Okay, I said it the other way around. If 4 times thickness is more than the length, then it will be taken in linear units. Okay. If it is less, then it will be taken as a separate wall. So you can see at the top, this is the actual wall without the projection. Okay. So you can see the 4.5 is the length of the wall, and 2.85 is the height of the wall. Okay. So this is without projection. And then since the projection 4 times of the thickness of projection is more than the length, okay, so the projection is only mentioned in linear units. Okay, what linear units? The thickness only. Okay, thickness. that means the other two units go where? The other two dimensions go in the description. Okay, the same thing which I mentioned for the wall. 2.85 is the height. Height, yes. Height. Sorry, height, yes. Height. Clear now? The thickness of the projection multiplied by 4.
And for constant.
Huh?
Constant.
4 is constant, yes. 4 is constant. So every time you have projection, you will multiply the thickness with the with 4, and you will check against the length. Okay. If the product of thickness into 4 is more than the length, then the projection will be just mentioned in linear units of the height. That's it. Okay. If thickness of the projection multiplied by 4 is less than the length, then the projection itself will be calculated in the meter square, same as wall, the actual wall. Got it? Clear? If you are going for the first option, then the length and thickness of the projection must be mentioned in the description. Okay. Now you take this example now. Okay. We have the same wall, but now the length of the projection is more. Okay. So 215 thickness multiplied by 4, it is less than the length. Okay. So now you can see the calculation. 3.49 into 2.85. This is for the, where is it? It's not this one. Not this one, right? Yeah, sorry. Then you have to you are basically calculating the this wall and this part of the wall. Okay. So 2.85 is the height. 2.85 is the height. Okay. Total wall is 4.5, right? Out of 4.5, how much is the projection? 1.1 something, right? Clear or not? No? You have the whole wall, okay, and this wall has a projection, okay. I check, should I take projection only in terms of height, or should I take projection as square meters? Okay, first check. Thickness multiplied by 4, it is less than the length, so I will take it as a separate wall. Clear? Okay, the first thing I found is projection should be taken as a separate wall. Okay, so this is one wall and these are two other parts of the wall. Okay, so the total wall was 4.5. Out of 4.5, I am taking this middle part separately, right? I calculate it separately. So from the total length, I will subtract this because this is separate. Okay, projection will be calculated. The part of the wall which has projection will be calculated separately. From the total, I will subtract this much. I will get 3.49. Okay, multiply by the height. So 3.49 is the total length minus the length of the projection. Clear?
It's 415 minus 1.115.
Yeah. Clear? Everybody? Okay. Then you come to the projection. We know the length of the projection, right? Length of the projection is 1.12. Okay. And the height of the projection, same as the wall. Clear? Okay. And you can see they have rounded off. It was 1.1115. They rounded off to 1.12, which is no problem. It's allowed. Clear or not? Okay. In the first case, you see that now the change in description as well. The first case, which is the normal wall, the thickness is how much? 215. Second case with the projection, the thickness is how much? 430. So what did we add here? the projection, the pair or the projection. Got it? So when you are calculating the projection separately, it's still length into height, but the description thickness will also change. Okay, in the first case which I showed you in the previous slide, no change. Okay, just need the height. Okay, so we have this case now. Okay, the height is 3.6 meters and we are using this type of bond which is called the English bond. So we are using bricks here. Okay, okay, so first of all, where do I have the projections? Anybody? Where do I have the projection? Bottom? Bottom? You are saying bottom or what? Which one?
No, the top one.
The top one. Bottom is what they call as an angle. Projection is, if there was a wall and this part was still there, then it will be a projection, like the top. This one is not a projection, it's an angle. The wall itself is going inside. Okay, it's not an extra part. Clear? Okay, so we have only one projection here. Let us apply the check. Okay, what was the check? 2? Where is the other one? Yeah, we have 2, sorry. We have this one and this one. We have 2. Okay, fine. So we apply the check on both of them. Okay, what was the check? 4 times of what? 4 times the thickness, right? So if I do it for the first projection, 4 times of thickness is how much? The top one, the thickness is 225. Multiply by 4, sorry, equals how much? 450 and 450, 900. Okay, what is the length of the projection? 1.3. So 4 times the thickness is less than the length, right? So it is less than the length. Okay, and so what was the rule in that case? We will take the projection separately. We will take it as an extra wall, a separate wall. Okay, with more thickness. Clear? Okay, what about this one? Again, 225 into 4, same 900, right? And the length is now 0.9. 0.9. Huh? It will be equal, yes, it will be equal. Okay, so equal is same as this one, the first case. Okay, equal is same as this one. Should be mentioned here. Okay, so we have both cases here. In the first case, I will take the projection separately. In the second case, I will take it as an just a projection, just the height. I mentioned the area on the other side. Okay, first of all, let us calculate the normal wall here. Okay, the normal wall. I have to, so I'll need the center line, right? Okay, these dimensions are for.
Last time you said when we have shape like this, we take the full area and
Yes.
then we deduct stuff.
Where is it?
Or we add.
When did I say this?
You said when we have like a regular shape now. It's not irregular, so.
Irregular, yes.
And then we minus down the one inside and the one and we add this one.
Why? We are not calculating area. We need the length. We need the length. So there is no minus or plus here. Just need the length. Okay. So if I take the length from here to there, okay, I have to subtract what? I have to subtract this one, 1.3, right? I will calculate separately. Okay. So, but is this center to center? It's not center to center. It's external. This is external. Okay. So, and the thickness of the wall is given here. It's not given here, right? Okay. Let's say the thickness is 200 millimeters. Okay, so I have 1.6 plus, 6.7 plus 1.8. Let me do it over here.
Eight
6.7 plus 1.8. I'll subtract because it is external, right? So in order to make it internal, I will subtract, right? Okay, I'll subtract half the wall from here, half the wall from here. Okay, so 2 into 100, right? The wall is 200, so 100 from each side. Okay, so this will give me this length, which is, and I have to subtract the projection as well, because I will take the projection separately. Okay, so projection is how much? 1.3. Okay, is this the same at the bottom? Without the projection. Okay, so I will still add, but I can go clockwise, no problem. Clockwise? It's clockwise? Yes, clockwise. Okay, so 0.8. I'm going clockwise. Okay, 3.9 again. Okay, because it's external, plus 2 plus 6.5 minus again this thing, then you go up, how much? Same, right? 0.9 plus 3, what am I doing? 0.9, 3 and the top, 0.8. 0.8 minus 2 into 100. Did I miss anything? Huh? No, but the projection is, now I will take it as linear. This is the other one. Did I miss anything? Yes.
So why would we make 2 multiply of 100?
Half of the wall. This is external, right? Half wall from here, half wall from here.
0.8.
Wall is,
This side 0.8.
which wall we are? Thickness of the wall. These dimensions are external. So I am reducing half thickness from here, half thickness from here. Six 1.8 is external.
Okay, that's
Okay.
yeah.
So minus 2 into 100 will give me center line. Half wall from here, half wall from here. Wall is 200 millimeters. The wall is 200 millimeters. Okay. The wall is 200 millimeters. Okay. So half wall from here, half wall from here. Then I calculated this side, which is 0.8 plus 3 plus 0.9. Again external. So half wall from here, half wall from here. Subtract. Because I need center line, right? Okay. So this minus this will give me center line.
So
Then this one.
Huh?
Huh?
You are keeping the thickness and millimeters.
I will keep the thickness in millimeters. Okay. Okay. Clear now? Clear now? Did I miss anything? I missed something. What?
0.8427.
Yes. This is not included here. This is extra. When you took this length, this part is included, right? Okay. But when you took this length, is this part included? No. This is extra. Okay. This inside angle is extra. When you took this one, you already took this one, right? Did you take this? No. Okay. So now I have to take this one as well. Clear or not? Okay. So I'll add this length and this length. Now this one you see is from here to here. This to this. If I take the center line, what will I do? What will I do? If I take the center line,
0.6.
I will subtract from here and I will add from here, right?
0.4.
Same, right? It will remain same. This is from this edge to this edge, right? If you want to get to the center line, you will subtract half wall from here. And if you want to get to the center here, you will add half here, right? So it will remain the same. Subtract half, add half. No? I want the length from center to center, right?
Yes.
Okay. This is from the outside. To get to the center, I will subtract half the thickness.
Yeah.
And I want center from here as well. So I will add half the thickness. Add, right? So subtract from here, add here. Same. Okay, it will remain 0.8. So I will add 2 into 0.8. Clear? Clear? Okay. Then I can now, no, I will do projection separately. Length of the projection, I'm talking about the top one, which I will take separately. Okay. So 1.3 the length, thickness 225 is a projection plus 200 wall. The top one. Okay. 225 projection, 200 wall. Okay. So for this one, you will do the total. Let's say the total is L. Okay. So the wall will be L, height 3.6. Clear? Okay. This is for the full wall. Okay. Then the top projection 1.3 length. I subtracted the projection, right? Yeah, I did. And the thickness will be 225 plus 200. 225 the projection, 200 the thickness of the wall. Okay. So it will be 4, 2, 5, 3.6. This is the top projection. Okay. And the projection on the side, I just mentioned the thickness and the area will go in the description. Okay. The area will go in the description. So the height is 3.6. That's it. This is the left projection, which is 0.9 by 0.225. Clear? Any questions? Height. Student. Okay. Okay. Anything else? Clear? Okay. See you guys next time.
No, no, no. Just
People are taking pictures. What are you doing? Yeah, what happened?
you want to clear.
Tell me, what is your question?
Okay, so he's asking